1 factorial is equal to 1, 2 factorial is equal to 2 into 1, 3 factorial is equal to 3
3
into
into 2
2
into
into 1, and 4 factorial is equal to 4
4
into
into 3 into 2
3
into
into
1.
2 into 1 is equal to 24, and this is equal to 6. 5 factorial is equal to 5
5
into 4
4
into
into
3
3
into
into
2
2
into
into
1
1.
is equal to 120.
20.
Okay. In general, we can say that n factorial is equal to n into n minus 1 into n minus 2 into so on up to 3 into 2 into 1. This is the n factorial. We have used the notation.
Okay.
Based on it, if you want to write this n factorial, you have start with n and then subtract 1, n minus 1, and then n minus 2, so on up to 1. This is n factorial.
Mm.
And then we have seen fundamental principle of counting. Fundamental principle of principle of counting. Fundamental principle of counting. Fundamental principle of counting means, suppose, let us take, there are 3 stations. Let us call this as station A, this is station B, this is station C. From A to B, a person can travel in 2 ways. Take it
Mm.
as rail, this is road. From B to C, he can go in 3 ways. That is air, this is ship, this is uh, this is train. Okay.
Mm.
Therefore, if a person wants to travel from A to C,
Okay.
A to C, number of ways is here A to B and then B to C. So this
Mm.
is 2 ways from A to B and 3 ways from B to C. 2 into 3 is equal to
6.
6 ways. So this is the fundamental principle of counting. So if one thing can be done in m ways, another in n ways, first one let us take m, second is n, then these two together can be done in m into n ways, mn ways.
Okay.
And there is another case. So in this case, these two things must be done one after the other successively. We consider another example. There is a kid. This is a small kid, and this kid has uh, dress. This kid has to be dressed. Okay,
Okay.
this is, we call it as upper dress. This is leggings, and this kid has got shoe also. So here shoes. Upper dress there are 3 types. Leggings say 4 types, and shoes is say 4 types. Okay.
Okay.
Then upper dress 3 ways, leggings 4 ways, shoes 4 ways. Unless all the 3 have been completely varied, we cannot say that the dressing of the kid is being completed. Therefore, number of ways she can wear upper dress is 3 ways, and leggings is 4 ways, shoes is 4 ways. Therefore, number of ways is equal to 3 into 4 into 4 is equal to 48 ways. So here we are especially or particularly using the word and is used. When and comes here also A to B and B to C, and is there. When and comes, this and indicates multiplication. Another case, this is case 1. There is another case 2. Case 2 means here R will come. R. Let us take a student can complete intermediate with a combination of MPC R by PC or MEC or HEC, isn't it? A
Mm.
student can complete an intermediate course with MPC or BPC or MEC or HEC or fashion technology also.
Okay.
So, is it necessary that if a student has to get through the certificate of intermediate, MPC and BPC? Need not. Any one of it, either MPC or BPC
IPC.
or MEC or HEC,
H.
like that. So, when R is there, this indicates plus. Plus. MPC, let us take it as one way, BPC one way, MEC one way, HEC one way, put together total is equal to 4
4.
ways. So we are getting the cases sometimes and first thing and then second thing. Whereas here in this case any one of it, either this or that or that or that, is when R comes we have to take plus plus plus. When AND comes we have to take multiplication.
Multiplication.
So these are the two different cases of fundamental principle of counting. After this, let us consider the permutation. Permutation is nothing but arrangement. Permutation is nothing but an arrangement.
Arrangement.
If there are two persons, A and B and A, this is there are two permutations. Two permutations are possible with AB and then BA. Suppose if you take there are three different objects are there, ABC, we are taking only two at a time, then AB, AC, BA, BC. Start with the C, CA, and then CB. So number of permutations comes here is equal to 6. And also we have seen that the 6 can be represented as 3p2, whereas this is equal to 2p2. 2p2. In this case, if we take all the three at a time, then A, B, C, A, C, B, B, C, A, B, A, C, C, A, B, C, B, A. Once again, you are getting the number of permutations is 6,
6.
and that is being represented as 3p3,
3P.
3,
3.
3p3. So in general, number of number of permutations is equal to, we have taken it as a number NPR. So NPR indicates number of permutations of n objects taken r at a time. N objects taken r at time is equal to npr. So npr is a number, it's a notation. npr is equal to a number. It is number of permutations. And also we have seen that npr is equal to n into n minus 1 into n minus 2 into so on up to n minus r plus 1. This is a formula you have derived in the previous class. And also this npr is equal to n factorial divided by n minus
Yeah.
r factorial.
Factorial.
So npr is equal to n into n minus 1 into n minus 2 into n minus 3 into so on n minus r plus 1 is one formula. And npr is equal to n factorial divided by n minus r
R
factorial.
factorial.
These are the two formulae we have derived in the previous class. And at the same time, if happens to be npn, npn is equal to n factorial. npn is equal to n
N
factorial.
factorial.
That also you have seen. After that, we have derived another formula also, npr. npr is equal to n minus 1 pr, n minus 1 p r plus r into n minus 1 p r minus 1, n minus 1 p r minus 1. This is also another formula you have derived in the yesterday's class. Remember?
Yes, sir.
Good. So for this npr, we have npr equal to n factorial by n minus r factorial. npn is equal to n factorial, and npr is equal to n into n minus 1, n minus 2, so on n minus r plus 1. This is another formula. And npr equal to n minus 1 pr plus r into n minus 1 p r minus 1. These are the formulae we got so far. And did you practice these formulae to remember?
Yes, sir.
Okay, good. Now, using this formulae, we can go for the problems also. So I'm arranging this. Already you have noted all those things.
Yes, sir.
Now we go to the problem number exercise 580 of page number 167. Did you complete yesterday's homework?
Yes, sir. Not fully, but I have doubts.
What's the doubt?
The first question which you gave homework, I couldn't complete full problem actually.
First question. Can you read out that question?
N plus 1
Hmm.
P5
N plus 1 P5.
by
Hmm.
NP6 is equals to 2 by 7. Find N.
N plus 1 P5. Okay, this sum. N plus 1 P5 is
By
by NP5.
NP6.
NP6, huh?
Uh,
No, NP5 only it is. N
NP5.
plus no, N plus by P N plus 1 P5 is to NP5 is equal to 3 is to 2.
Okay.
N plus 1 P5, you can take it as start with N plus 1 into N into N minus 1 into N minus 2 into N minus 3, 5 factors,
Yes.
divided by NP5, N into N minus 1 into N minus 2 into N minus 3 into N minus 4. Once again 5 factors is equal to 3 by 2. Possible cancellations n, n minus 1, n minus 2, n minus 3.
It is 2 by 7.
2 by
7.
2 by 7. Ah?
Ah, the question is n plus 1 p5 by np6, I think so, is equals to 2 by 7. That is the question. Easy.
Okay, this is another question. Okay, okay, right. This question is different, that question is different. Okay.
Yeah.
Now the question is n plus 1 p5. And this is third one of page number 166. N plus 1 p5 divided by np6 is equal to 2 by 7.
Mm.
That is given to you. So this is implying n plus 1 p5 means n plus 1 into n into
And
n minus 1 into n minus 2 into
n
n
minus 3.
3 divided by n into n minus 1 into n minus 2 into n minus 3 into n minus 4 into n minus 5
Mm.
is equal to 2 by
2 by 7.
possible cancellations n minus 1 n minus 2 n minus 3. Okay,
Mm.
so this is implying n plus 1 divided by n minus 4 into n minus 5 is equal to 2 by 7. Let us take cross multiplication. 7 into n plus 1 is equal to 2 into, we have to multiply these two. I will
Okay.
write the product. N into n is n square minus 4n minus 5n minus 9n minus 4 into minus 5 plus 20. This is implying 7n plus 7 is equal to 2n square minus 18n plus 40. Bring all the terms to right side. First n square term we write minus 18 minus 7 minus 25 n plus 40 minus 7 plus 33 is equal to 0. Now we have to find factors for this 2 into 33. Sum is our difference sum is 25. So let us
Mm.
take 2 into 33 means uh, what are the factors? 22 into 3 na 22 into 3. So this is 2 into 33. This is 2 into 3 into 11 is equal to 6 into 22 into 3. Let us take 22 into 3. 22 plus 3 is 25. Therefore, we can write this as 2n square minus 25n. We write it as minus 22n minus 3n plus 33 is equal to 0. Following?
Yes, sir.
Now common between these two. 2n is common.
2,
n minus 11 minus 3
3.
n minus 3 into n minus 11 is equal to 0. This is implying 2n minus 3 into n minus 11 is equal to 0. So this is implying n is equal to 3 by 2 and n is equal to 11. But 3 by 2 won't be there. 3
Yes,
by
sir.
2 is a fraction won't be there. N is equal to 11. So this is the answer.
Okay.
N is equal to 11 is the answer. And else more, which you
Yes,
did
sir.
not.
Second question. N plus 1 P5 is to n P5 is equals to 3 is to 2.
Hmm.
I completed only half.
Only half, huh?
I didn't get it after that.
This problem we did not do yesterday.
You give it as a homework, no?
This one also, no?
Hmm.
Now n plus 1 p5 is to np5 is to is equal to 3 is to 2. That is half completed, huh?
No, so you gave it as a homework. I completed half at home.
Mm-hmm. So, what was the last step you got for that problem?
Uh, n plus 1 factorial by n minus 4 factorial by
Hmm.
n factorial by n minus 5 factorial is equals to 3 by 2.
Hmm. That's all.
Till that I did.
Okay. So, this is. Did you copy down this?
Yes, sir.
Shall I erase?
Yes, sir.
Now, this is example 3 of 159. N plus 1 p5 divided by np5
Hmm.
is equal to 3 by 2. N plus 1 p5 means n plus 1 into n into n minus 1 into n minus 2 into n minus 3, 5 factors, divided by np5 n into n minus 1 into n minus 2 into n minus 3 into n minus 4 is equal to 3 by 2. Now n is cancelled, n minus 1 cancel, n minus 2 cancel, n minus 3 cancel. Remaining, if you take this is n plus 1 divided by n minus 4 is equal to 3 by 2. Isn't it?
Yes, sir.
Hmm. Then this is implying cross multiply. 2 into n plus 1
I
is
did in a different method, maybe.
you did in different method. I will do in the same method only.
Okay.
So what you did is n plus 1 factorial divided by n plus 1 minus 5
Minus
factorial,
5.
is it not?
Yes, sir.
Divided by, this is n factorial divided by n minus 5 factorial you did,
Hmm.
is equal to 3 by 2. So numerator is n plus 1 factorial, n plus 1 factorial divided by n plus 1 minus 5 is n minus 4 factorial, isn't it?
Yes, sir.
N minus 4 factorial by, that comes to the adjacent reverse. Here n factorial will be in denominator and this goes to numerator. N minus 5 factorial goes to numerator is equal to 3 by 2. This n plus 1 factorial is n plus 1 into continuation n factorial. After n plus 1, n will come, subtracting 1,
Okay.
n factorial divided by n minus 4, after that n minus 4 minus 1, n minus 5. Therefore, it is n minus 4 into n minus 5 factorial.
Sir, I didn't understand that.
N minus 4 is there, na?
Hmm.
N minus 4, next factor is n minus 4 minus 1,
Ah,
n minus 5. N
okay.
minus 4, n minus 4 minus 1 is n minus 5
5.
factorial into, this is n minus 5 factorial divided by n factorial is equal to 3 by 2. Here the technique is we should convert them into the factors where they will get cancelled.
Sir, for n minus 5 factorial, we can do the same, no?
They will cancel.
Ah, okay, okay.
They will cancel. So what is left over now? N plus 1 divided by n minus 4 is equal to 3 by 2. So this step both are same. Both are
Okay.
same. Instead of applying formula here, why I applied here is because writing 5 factors is easy. N plus 1, n minus 1, n minus n minus 3. Here also just 5 factors, so we can better write. If you apply the formula here, you have to think what is after next factor, n plus 1 or n plus 2 or n. Like that you have to think and then simplify. It is a cause of some thinking. That's why directly I have taken like this. Okay. Now
Okay.
what happened is
Cross multiply.
cross multiplying we are doing. Once if we cross multiply, it becomes a 2n plus 2 is equal to 3n minus 3 fours are 12. This plus 2n goes to right side as 3n minus 2n. Plus 12 comes to left side as 2 plus 12. So 2 plus 12 is equal to 14. 3n minus 2n is n. Therefore, answer is n is equal to 14.
14.
Like that.
Okay.
Copy it fast.
Done.
Now, completed.
Yes, sir. Yes, sir.
Now let us come to the second Roman of this exercise. First problem. There are 25 railway stations on a railway line.
Okay.
So 25 railway stations are there. 1, 2, 3, so on, so on, so on, so on. 25. 25 stations are there. And how many types of second class tickets must be printed so as to enable a passenger to travel from one station to another? So did you copy down the problems?
Sir?
Yesterday I sent photos.
Yes, sir.
Did you note it down the problem or not?
Which
Not.
one, sir?
Problems were not noted down. Okay, anyhow, simply listen, I will send the photographs once again. You can note down the problem because you have no textbook.
Okay, sir.
And there are 25 railway stations on a railway line. 25 railway stations are there. Let us assume that from this point to this point there are 25 railway stations. How many types of single second class ticket must be printed? So this is a department, railway department question it is. It's a second class ticket. Assume that it's a second class ticket. How many types of tickets must be printed so that a passenger to travel from one station to another? So generally, if we go to the station wants to travel by this train, we ask for a ticket. Ticket means we have to indicate two important things. Number one is from, and number two is to. From and then to. From first station to, from any one of these last stations we will ask the ticket. So when we ask the ticket, what that station master does is, in ticket collector does is, he print the ticket and then give it to us. So how many points he has to fill? How many places he has to fill? From place and then to place he has to fill.
Mm.
Therefore, number of places to fill is 2. That is R is equal to 2. And from how many he has to select? From this 25 names he has
25.
to select. Is it not?
Yes, sir.
From this one of the two of these 25 names he has to select and then print over here. Then only this ticket is valid for this route. Understood this point?
Yes, sir.
So number of ways of filling 25 in two different places. Formula is NPR.
Mm.
Number of ways is equal to formula is NPR.
R.
NPR means 25p2. 25p2 means 25 into 24 only. Only two factors. 25 into 24 is equal to 600. Following?
Yes, sir.
So this is a practical thing we have to think how the ticket is being printed from and then to. These are the important things. Then all ticket is valid.
Okay, sir.
And if we fill these two places, a passenger can travel from one station to this station to that station, here to there, there to here, like that, like that, like that. He can travel between any two stations. And also you should remember, no one is asking that, sir, please give me a ticket from first station to second, second to third, third to fourth, fourth to fifth. Like that, no one asks, no?
Yes, sir.
We simply say that first to is destination somewhere else. So only from and then to is to fill. Hence, the number of places to fill at a time is only 2 from this 25 only. That's why n is equal to 25 and r is equal to 2. Number of ways is equal to npr. So in this type of problems, it's a theory based problem. That means that they want to give n value, they won't give r value. We have to read the problem and then we ourselves have to decide what is the value of n and what is the value of r. Now let us consider next question, second question. There are 30 students in a class. There were 30 students are there. 30 students are there. And these 30 students, what they are doing is, on the New Year day, every student post a greeting card to all his classmates. Find the total number of greeting cards posted by them. So occasion is New Year. New Year. So 30 students are there. Greeting card is being exchanged between how many at a time? How many students at a time?
2.
Two only. Good. Isn't it? Therefore, between these 30 students only it will be done because 30 are the only students available to us and given to us. Hence, n is equal to how much?
30.
And r is equal to how much?
2.
2. Number of arrangements or number of exchanges is
NPR.
good. Number of exchanges is equal to NPR. That is equal to 30p2. 30p2 is equal to 30 into
29.
29. How much it comes? 0, 7, 2, 3 to the 6, 870. So this is the number of greeting cards exchanged.
Okay, sir.
Next is third one. Third one is, find the number of ways of arranging letters of the word triangle. A word is given here. Triangle. A word is given. Number of ways of arranging letters of the word triangle so that the relative positions of vowels and consonants are not disturbed. T position is 1. This is second, third, fourth, fifth, sixth, seventh, eighth. These are the positions of the letters. Among them, vowels if you take. What are the vowels available in this triangle? A, E,
R.
I,
Yes, sir.
I, A, E.
E.
So I, A, E, I, A,
E.
E. I is in which place? Third place.
Third
Huh?
place.
A is in,
Fourth place.
E is in,
Eighth place.
yes. So I, A, E, they are in third, fourth, and then eighth places.
Yes,
These
sir.
three vowels must be in their respective places only. That means three letters are there. For them, three places are available. Therefore, how many ways vowels can be arranged in their respective places?
Sir, I didn't understand.
There are three vowels.
Okay.
Here the question is TRA, ANGLE is given.
Hmm.
What have we to do is we have to rearrange all the letters.
Hmm.
R here, T there, I, A, they can all be interchanged. There are 8 letters. 8P8, 8 factorial arrangements will come if no condition is put. Okay.
Okay.
NPR, N is equal to 8, R is equal to 8, 8P8.
Hmm.
But they are putting a condition to us. The condition is vowel is there no, I, A
Hmm.
is there no,
Hmm.
E is there no,
Hmm.
I third place, A fourth place, E eighth place.
Eighth place.
These three vowels in these three places only, third, fourth, eighth only. This I should not go to second or first or
Okay.
fifth or sixth or seventh place. I, A, E should be in third, fourth, and then eighth
Eighth.
place. Like that, we have to arrange.
Okay, sir.
How many arrangements will come? That's the question. So what we were doing is, first we are going to arrange the vowels and then remaining letters, consonants.
Okay, sir.
How many vowels are there?
Three.
How many places are there for them?
Three.
Three. How many ways we can arrange them?
Three.
3, P, 3. 3, P, 3.
Three.
Here in this case, N is equal to
Three.
3. R is equal to
Three.
3. Number of arrangements is, formula we have is
Three. P3.
NPR, that's equal to 3P3.
P3.
Always you should remember this NPR. Permutation, NPR. That's all.
Okay, sir.
So vowels can be arranged in how many ways? 3P3.
Three. Three. P3.
About consonants we consider. Consonants. What are the consonants available here? T,
T. R.
R,
N.
N,
G. L.
G, L. T is in first place, R is in second place, N is in fifth place, G is in sixth place, L is in seventh place. So how many letters are there?
Seven.
Uh,
Sorry.
five, five.
Five. Five.
How many places are there?
Five.
Five. How many ways we can arrange these consonants?
Five.
Uh-huh. Five. Here N is equal to how much? R is
Five.
equal
Five.
to number of arrangements?
Five. P5.
That's good. Number of arrangements is equal to, once again the same formula, NPR. 5P5. Understood?
Yes, sir.
This is 5P5 is the arrangements of consonants. 3P3 is the arrangements of vowels. So we have to do both one after the other, isn't it?
Yes, sir.
Both we have to do. Vowels we have to arrange as well as consonants we have to arrange. Therefore, required number of arrangements are total number of arrangements. Required number of arrangements. Required number of arrangements is equal to 3P3 into 5P5.
P5.
That's equal to 3 factorial into 5 factorial. That's the answer. Understood?
Yes, sir.
Hmm. So you should always remember the formula NPR. NPR, 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 like that you have to remember in this permutation chapter.
Okay, sir.
What are the things you have to do is search for N and then search for R. N
Okay.
is always greater than R or equal to R.
Hmm.
Or more value is to be taken as N, less value is to be taken as
R.
R. If both are same, both are equal. Formula is always
NPR.
NPR. Like that you have to think. Not on this.
Yes, sir. Over.
Over.
Yes, sir.
So I will erase this. After this, let us consider number 4. I will write the question also. You note down the question also
Okay,
because
sir.
you have no textbook. Find the. Oh, 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 we do the fifth sum, fourth sum after that. Fifth sum
Okay.
first. Find the numbers, number of number of numbers greater than greater than 4,000, greater than 4,000 can be found using using 02468 02468 without repetition. Without repetition. Okay,
Yes, sir.
so we have to find a number which is greater than 4,000 using 02468 without repetition. For this we have to find a solution. Now the numbers which are given to us is 0, 2, 4, 6, 8. We are considering 4-digit numbers. 4-digit numbers. Four-digit numbers means you have to fill 4 boxes, isn't it?
Yes, sir.
Let us take every dash is a box. But here the number should be greater than 4,000. Suppose if I keep this is units place, this is tens place, this is hundreds
100.
place, this is
1000
thousands
rupees.
place. If I keep 2 here, it becomes 2,000.
Yes, sir.
If I keep 4 here, it becomes 4,000.
4000.
So this place can be filled with
6 or 8.
either 4 or 6 or 8,
8.
isn't it?
Yes, sir.
4 or 6 or 8. So how many ways
3 ways.
this place can be filled in? 3 ways. Into there are still how many places to fill? 3 places.
3.
Suppose we would have used 4 here. Suppose 4 is used. Then how many numbers are there yet to use?
4.
1, 2, 3, 4.
Hmm.
So there are 4 numbers are there. I will let the numbers also here. Suppose if 4 is used, available digits are 0, 2, 6, 8. Suppose 6 is used, then the place of 6 will go here and 4 will come here.
Yes, sir.
Suppose if 8 is used, 8 will go there and then that 6 will come to this place. Okay.
Hmm.
So there are three places and available digits is 4. 3, 4. N is 4, R is 3. Number of ways is
N
NPR.
NPR.
Correct. NPR. That means 4p3. Is it not?
Yes, sir.
N is 4, R is 3, 4p3. Therefore, this place can be filled in 3 ways. These 3 places can be filled in 4p3 ways. Therefore, together it comes as 3 into 4p3. This is equal to 3 into 4p3 means 4 into 3 into 2. 3 factors.
Hmm.
On multiplying, we will get this is 3 2s are 6. This is 12. 12 into 6 is equal to 72. These are all 4-digit numbers. Okay.
Okay.
All these 4-digit numbers are which are greater than 4000. 4-digit numbers greater than 4000 we have calculated. And shall we consider 5-digit numbers?
Okay, sir.
Shall we say that 5-digit numbers also greater than 4000?
Yes, sir.
Any 5-digit number, is it greater than 4000? Any 5-digit number?
Yes, sir.
Yes, good. 3, 4, 5. So this is units place, tens place, thousands place, hundreds place, thousands place, 10,000 place. This 10,000 place, if we consider, that should be filled with the non-zero digit. Non-zero. Non-zero means 2,
Four,
4,
six, eight.
6, 8.
Eight.
So how many ways?
4 ways.
4 ways. Here you have to fill 4 places and digits available is equal to 1 is used. No? What are
Hmm.
the available digits? I will write here also. 0 is not used. Suppose 2 is used. 4 is available. 6 is available. 8 is
8.
available. So n is equal to
4.
number of permutations is
4p4.
very good. Therefore, this is equal to 4 into
Into
4 means 4 into
into 3
2
into 2
into
into 1.
equal to this comes as 4 into 4 is equal to 16 into 3 2s are 6. So 16 6 are 96 are 96.
Huh, 96.
Therefore, total number of numbers greater than 4000 uh, is equal to 72 4-digit number and 96 5-digit number is there. Now
Yes,
shall
sir.
we find 72 4-digit number and 5-digit number or 4-digit number or 4-digit 5-digit number? R or and which is to kept here?
I didn't understand, sir.
We are forming 4-digit numbers. Huh?
Yes, sir.
We are forming 5-digit numbers also. Nah?
Yes, sir.
Shall we add or multiply? Here,
Add.
add. That's good. Why? Because we may form a 4-digit number or a 5-digit number, isn't it?
Yes, sir.
If we write a 4-digit number, we are not going to write 5-digit number. If we write a 5-digit number, we are not going to write a 4-digit
4
number.
digit number.
That's why any one of it will be done. If any one of it will be done, then we have to put plus. So 72 plus
96.
96. The total comes is find out the total and tell me.
Yes, sir. 168.
168. So the answer is 168. That's the answer for this problem. Okay,
Yes, sir.
note it down. Good. Now next thing is question number 6. 167. Find the number of ways of arranging letters of the word Monday so that no vowel occupies even place. Monday is given. Monday. So 6 letters are there, but no vowel occupies even place. Condition is no vowel is in even place. Vowel is not in even place means where does this vowel should go? For odd place only. This is place number 1, place number 2, place number 3, place number 4, 5, 6. What are the vowels? O,
O A.
O, E. These are the only two vowels. What are the places allotted for them?
2 and 5.
No, no, no. They
Hmm.
should not be in even place. Place.
1
Odd
3 5.
place. 1,
3 5.
5. Okay, na?
Hmm.
Vowels are there only O and A, and places for them is 1, 3, 5.
Hmm.
Vowel is should not be in even place.
Even place.
So what is the value of n here?
3.
Good. Or
3.
uh,
2
uh,
2 2.
good. N is 3. I will write here. N is equal to more value. R is equal to less value.
Hmm.
Number of arrangement of vowels is equal to formula.
NPR.
That's equal to value
3P2.
is equal to 3 into
3
is
into
equal to 6.
2.
Okay, so
Hmm.
we have found the arrangement of vowels. Now we look for the consonants. Consonants. Now tell me what are the consonants available to us? M,
MNDY.
D, Y.
Y.
Good. Places available. Consonants elsewhere they may be, no?
Yes, sir.
How many places are used so far?
6. Sorry. 3.
Uh, uh, 2 places only, no?
2 2 2 2. Sorry, 2.
2. Out of 6. So number of places
4.
available. Number of places. Vacant, I will write. Vacant is equal to totally 6 places. We have used only 2. Balance is 4.
4.
Here also 4 letters are there, na?
Hmm.
M and dy. Now tell me what is N?
4.
R.
4.
Good. Therefore, number of arrangement of consonants is equal to formula.
4.
Yes.
NPR.
Good.
4P4.
How to find the value of 4p4?
4 into 4 into 3 into 2 into 1.
Is equal to
So 4 into 4, no?
no. Start with 4. Write 4 factors. Start with 4. 4 factors. 1, 2, 3, 4. That's all. 4p4 is 4 factor line, no? 4 factorial means 4 into 3 into 2 into 1 is equal
Okay.
to 24. Okay.
Okay, sir.
So therefore, total arrangements we have to find. Total arrangements. Total arrangements is equal to here vowels how many ways? 6 ways. Huh?
6,
Consonants 24 ways. Huh?
24.
6 into 24 is equal to 144. Huh? So 144 ways we can arrange. Okay.
Okay, sir.
Note on this.
Over, sir.
These questions are been asking in the examination for all competitive exams. And at the same time for intermediate. In either way they will be asked. So we should practice them thoroughly.
Okay, sir.
Now, sixth question is over. Huh?
Yes, sir.
Seventh question. Find the number of ways of arranging 5 different math books. Here, 5 math books are there, and 4 different physics books are there. 4 physics, and then 3 different chemistry books are there. 3 chemistry. Okay, 5 maths, 5 maths, 4 physics, 3 chemistry books are there. Uh, Such that the books of the same subject are together. So same subject books should be together. Like that you have to arrange them in a line. 5 different math books means we take one is algebra,
Calculus.
trigonometry, calculus. Tell.
Algebra, trigonometry, calculus.
Hmm. Geometry.
Geometry.
Geometry. Inka mensuration
Mensuration.
or statistics. Just take like that. Okay.
Okay.
Physics. Tell me 4 different physics books. Light,
Light.
optics, ఇంకా current,
Motion.
motion. Yes, 4 books are there. Chemistry, physical
Chemistry.
chemistry, organic chemistry,
Chemistry. Environmental chemistry.
environmental chemistry. Okay, so all are different books now, but these 5 books comes into one category. These are all maths.
Yes, sir.
These 4 is into one category. This is physics. These 3 into one category, chemistry. You are asked to arrange them in a shelf, in your bookshelf. You have to arrange. But the
Yes,
thing
sir.
is, these 5 should be at together. This math book should not join with chemistry, physics, and this physics book should not mingle with maths, and between chemistry book should not come. Like that, you should not jumble them. All maths first, and then physics, and then chemistry. If this is the condition, did you understand the condition?
Yes, sir.
Ah, if it is the case, actually, what will you do to arrange them? What will you do means you will be tying up these 5 math books. Put a tie for them. Take a strong rope and thread and tie them. Another tie for this 4 physics. Next tie for this 3 chemistry. So that if you just pull the bundle, it all put together. It's a bundle. It comes in, isn't it?
Yes, sir.
All the mass will be together. This is another bundle. This is another bundle. These three bundles can be interchanged. This physics may go like this math may come like this, or else this may go like this, that may come like this. These can be interchanged in all possible ways, so that math will always be together, physics will always be together, chemistry will also be together. Is it not?
Yes, sir.
So, how many bundles are there?
3.
Three bundles. How many places are there for them?
3.
Good. So n is equal to 3, r is equal to 3.
3.
Number of arrangements is
NP, NPR.
good. Value arrangements in
3PR. 3P3 is equals to 3 into 2 into 1.
very good.
6.
NPR is equal to 3P3 is equal to 3 into 2
2
into
into
1.
1.
Very good. Okay.
Mm.
But there is another condition to be considered. While putting a tie for them, probably you may like algebra when compared with all the remaining four subjects. You prefer to keep algebra first, isn't it?
Okay.
Suppose if you are not interested in algebra, you always interested in trigonometry, you keep trigonometry first and algebra next,
Yes, sir.
isn't it? So there are five internal changes can be made among the math books itself. Is it?
Yes, sir.
There are five books. These five can be interchanged among themselves while tying. In how many ways? For this mass, 5. N is 5. R is 5. So number of arrangements is
5P5.
5P5 arrangements will be done. Whereas among the physics themselves, how many arrangements?
4.
4. Hmm,
4P4.
4P4.
4.
Among chemistry?
3P3.
Excellent. 3P3. Isn't it? So how do you get this 4P4? This is nothing but internal changes among physics themselves. If you interchange the second book to first book to second place, physics is being together. No condition. Condition is not violated. Hence, the physics books can be interchanged among themselves in 4P4 ways. Chemistry books can be interchanged among themselves in 3P3 ways.
3P3.
Similarly, math books can be arranged among themselves in 5P5 ways.
5P5.
All together 3P3 ways. Okay, na? Therefore,
Okay.
mass internal arrangements is equal to 5P5 is equal to 5 factorial. Physics internal arrangements is equal to 4P4 is equal to 4 factor. Chemistry internal arrangements is equal to 3P3 is equal to 3 factor. Okay.
Okay, sir.
Overall arrangements MPC arrangements maths, physics, chemistry. Okay.
Okay.
Arrangements is called already have calculated now 3P3.
Yes, sir.
One more 3P3 is there now. 3P3. Therefore, total arrangements is equal to 5 factorial into 4 factorial into
Y
3
into
factorial into 3 factorial. Why into? First, you are not arranging five pharma mass among themselves,
Yes, sir.
and physics is not,
Yes, sir.
and chemistry is not,
Yes, sir.
and also MPC arrangements.
Okay.
You have to do one after the other, is not? All are possible. This you have to do, and this you have to do, and. That's why into will come.
Okay, sir.
Okay. So I need not multiply it. That they can leave it. So this is the answer. Hence, the internal also taken into consideration. Number of arrangements is equal to this much, and it comes as 1 lakh multiplication. You have to complete. I will write only the answer. The computation. And now is the second row. Seconds.
Hello. So your voice is
Yeah.
breaking.
Voice is breaking.
Yes, sir.
Now is it okay?
Now it is okay.
Okay, right. Complete it.
Over, sir.
Over.
Yes, sir.
So with this, the 4 marks questions are over. Now we are going to the long answer questions.
Okay, sir.
Third part, 7 marks questions. Now here given, find the number of 5 letter words that can be formed using the letters of the word consider. Consider is given among. First question is CONSIDER. Consider is given to us. Number of 5 letter arrangements is asked. 5 letter arrangements. How many is asked? First part. Now, how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. 8
8.
is here, and we are considering 5 at a time. Now, what is the value of n?
8.
Or
5.
number of arrangements?
8p5.
Good. Eight p five. 8p5 is equal to 8 into 7 into
Into 6
6
into
into
5 into
5 into
4.
4. That's all. We can multiply and find it later. Okay.
Okay.
Now they are putting some condition asking the same question. First part is first condition is how many of them begin with C? Begin with C is the condition. Begin with C is the condition. So let us take 5 places as usual. Begin with C means C should be kept in the first place.
Yes, sir.
C should be kept in the first place.
First place.
How many places are vacant still?
4.
How many letters are there yet to use?
7.
Good. So what is the value of n? Number of arrangements. Ah, tell number of arrangements is
7p4.
good. You need not find it, just leave it.
Okay.
Second part. How many of them end with R? End with R is the condition. End with R is R. R is the condition. So let us consider as usual 5 places. This last place should be fixed with R,
R.
and remaining 4 places can be filled in how many ways?
7.
7 letters are there, places are
4.
4. Number of arrangements is
7p4.
good. Same thing. Shall I write? Therefore,
Okay.
number of arrangements. Same formula. Uh, understood how we take n is 7 and r is 4?
Yes, sir.
Good. Third part. Third part of the question. And how many of them begin with C and end with R? Condition is begin with C and end with R. Begin with C and end with R is asked. So what I have to do is 5 places we take. Here we fix up C. Here we fix up
R.
R. How many places are still to fill?
3.
How many letters are available to us?
6.
6. Good. So what's the value of n?
6.
R value?
3.
Number of arrangements?
6p3.
Good. Number of arrangements is equal to 6p3. That's over. This is a long answer question for 7 marks.
Okay.
Understood?
Yes, sir.
Note it down.
Over, sir.
Okay. Now let us see the second question of this. Am I raising?
Okay, sir.
Now second question. Here given there are 10 persons. Find the number of ways of seating 10 students A1 to A10 in a row. A1, A2, A3. Okay. A1, A2, A3. So as far as A10. There are 10 persons are there. They are all sitting in a line. All sitting in a line. So how many ways they can sit without any condition?
I didn't understand, sir.
There are 10 persons.
Okay.
How many ways they can sit in a line?
10 ways.
Uh-huh. Number of persons is 10.
10.
How many places are there for them? Places. Not following.
Sir, can you repeat the question?
There are 10 of your classmates are there.
Okay.
All these 10 are sitting in a line.
Okay.
How many persons are there?
10.
How many places are there for them?
10.
10. So how many ways they can sit?
10.
Uh-huh. You are saying n is equal to how much?
10.
R is equal to how much?
10.
Number of ways is how much?
Oh, sorry. NPR. 10p10.
I should not forget that formula. Permutation. How many arrangements? Number of permutations is equal to 10p10.
NP10.
10p10 is equal to 10 factorial. 10 factorial means 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 1 thousands of times will come.
Okay, sir.
Understood? So all possible arrangements without any condition is 10 factorial ways.
Yes, sir.
Now they are putting a condition. First condition is A1, A2, A3 sit together. A1, A2, A3 sit, they should sit together.
Together.
This is the condition. A1, A2, A3 always should sit together.
Yes,
Okay.
sir.
What we do is, listen carefully.
Mm.
I will take A1 here, A2 here, A3 here, A4, A5, A6, A7, A8, A9, A10. These three should always be together. So what I do is, I will arrange a bench for them.
Okay.
One bench. These are all chairs. One, this is two, three, four, five, 6, 7, 8. So for each person there is chair, and for these three together there is a
One.
bench.
Okay, bench.
How many places are now there for them?
8.
8 places are there. Is not?
Yes, sir.
So in these 8 places they will be interchanging. That means the bench itself will move like this. Bench alone will move. All the three will be sitting in the bench only. So
Okay.
these three will be together.
Mm.
How many ways they can be arranged now? These 8, how many ways they can be arranged?
N is equals to.
Is it not? N is equal to
So
8.
not 10. No?
No, ma. These three together one unit.
Okay.
నువ్వేం చేస్తావు అంటే వీళ్ళ ముగ్గురు కదలకుండా ఒక గట్టిగా తాడేసి కట్టేసేయి.
Mm.
వస్తువులు అయితే తాడేసి కట్టేస్తాం.
Ah.
మనుషులు అయితే బెంచ్ బెంచ్ వేసి కూర్చోండమ్మా అని చెప్పేస్తాం.
Ah.
అంటే ఈ బెంచ్లో ఉండే ముగ్గురు ఒక్కసారి ఏమంటారు, బెంచ్ కదులుతుంది ఇక్కడికి. అంటే ఇక్కడ ఒక
Okay.
బెంచ్ ఇట్లా వచ్చేస్తుంది, ముగ్గురు ఇక్కడ కూర్చుంటారు, ఇక్కడ ఒకరు వస్తారు, లేదా ఒకరు ఇద్దరు రావచ్చు, బెంచ్ ఇక్కడ ఉంటుంది, ఇట్లా మూవ్ అవుతుంటారు అనమాట వాళ్ళు.
Okay.
కాబట్టి మూవింగ్ ఎన్ని అయినాయి ఇప్పటి మనకు?
8.
8 అయినాయి. ప్లేస్లు ఎన్ని అయినాయి? ఇదంతా ఒక ప్లేసే కదా.
Ah.
8 ప్లేసెస్ అయినాయి.
8.
హౌ
8
మెనీ
p
8
8.
8 ఓకేనా.
Ah.
సో అరేంజ్మెంట్స్ ఈజ్ ఈక్వల్ టు 8p8 8 ఫ్యాక్టోరియల్ రాసుకోవచ్చు. ఓకే, అర్థమైందా?
Yes, sir.
అయితే ఇక్కడ ఈ ముగ్గురు ఏంటంటే A1 A2 A3 వాళ్ళు కలిసి ఉండాలి అని చెప్పారు. దే ఆర్ టుగెదర్ అన్నారు.
Mm.
ఇప్పుడు ఏం చేద్దామంటే మనం వీళ్ళని ఇంటర్చేంజ్ చేయొచ్చుగా. అంటే A2 A1 A3 A3 A1 A2 లైక్ దట్.
Ah.
They are being together, but they can be interchanged among themselves. How
Okay.
many ways these three can interchange among themselves in the 3 places?
In 3 places. 3.
3 persons, 3 places. How many ways they can interchange? How many arrangements will come here?
3.
Uh, uh,
3 p 3.
3p3 arrangements will come. Understood?
Yes, sir.
So for these 3, number of arrangements is 3p3. Following?
Yes, sir.
So these 3 persons can interchange among themselves in the bench itself in 3 factorial ways. The
Yes.
bench and then these remaining chairs will move together 8 in 8 factorial ways. So A1, A2, A3 internal arrangements. Internal is equal to 3 factorial or 3p3. Okay.
Yes, sir.
So we have to do this as well as this also, na?
Yes, sir.
Therefore, number of total, right? Total number of arrangements is equal to what have to multiply or add?
Add or
Uh,
multiply.
multiply, because we have to do this and also this, and is there. So if you
Okay.
do any one of it, suppose if we arrange only these three, what about the remaining? If you arrange only this eight, what about themselves? So both you have to do.
Okay.
Therefore, you have to multiply 8 factorial into 3 factorial. Whereas if we consider the second one, second
Mm.
part of the question. Second part of the question is A1, A2, A3 sit in a specified order. Before second, I go to the third one. Third is very similar to this. A1, A2, A3 sit together in a specified order. Here A1, A2, A3 sit together in a specified order. So we want to find the number of arrangements. Wants to find the
Number
number
of
of
arrangements.
arrangements. So what happens here is that this is the different condition when compared with the previous one. Previous is A1, A2, A3 sit together only. సిట్ టుగెదర్ అంటే కలిసి కలిసి కూర్చోవాలి, పక్క పక్కన కూర్చోవాలి అని. ఇక్కడ
Mm.
ఏమంటున్నారంటే A1, A2, A3 సిట్ టుగెదర్ ఇన్ ఏ స్పెసిఫైడ్ ఆర్డర్. స్పెసిఫైడ్ ఆర్డర్ అంటే ఫస్ట్ 1 రావాలి, తర్వాత 2 రావాలి, అండ్ దెన్ 3 రావాలి. వాళ్ళలో వాళ్ళు ఇంటర్చేంజ్ అవ్వకూడదు.
Mm.
అది డిఫరెన్స్. కాబట్టి వీళ్ళంతా కలిసి కూర్చోవాలంటే ఈ ముగ్గురికి మనం ఏం చేద్దాం?
Bench.
ఒక బెంచ్ చేద్దాం. ఓకేనా? బెంచ్ మీద కూర్చోబెడదాం వీళ్ళను. ఇక్కడేమో A1, ఇక్కడేమో A2, ఇక్కడేమో A3.
A3.
మిగిలిన వాళ్ళకి చైర్స్ వేద్దామా? 1,
Ah.
ఇంకా ఎంతమంది? 7 మంది ఉంటారు కదా.
Ah.
3, 4, 5, 6, 7 చైర్స్ వేసాం.
Mm.
ఇవన్నీ కలిపి ఎన్ని ప్లేస్లు వచ్చాయి మనకు?
8.
8 వచ్చాయి. 8 రాసానా?
Mm.
సో ఇక్కడ 8 వచ్చాయి. మరి n ఈజ్ ఈక్వల్ టు ఎంత?
8.
r ఈజ్ ఈక్వల్ టు
8.
8 ఓన్లీ.
Mm.
దిస్ ఈజ్ 1 యూనిట్ కదా.
Ah.
Second, third, fourth, fifth, sixth, seventh, eighth. 8 places are there for them. Persons also 8 only, because
Mm.
we are treating these three as 1 unit.
Okay.
Therefore, n is equal to 8 and r is equal to 8. Number of arrangements is equal to
8 p.8.
good. Number of arrangements is equal to 8p8 is equal to 8 factorial. We should not interchange these three among themselves, because they are put in the condition they should sit in a specified order. Okay na?
Okay.
Adi. So these two are almost similar, whereas here internal changes are considered as 3p3. Here we are not going to consider the internal changes. Next is the second part. You copy down this first.
Yes, sir. So, hello.
Completed?
Yes, sir.
Okay. Now we take the second part of the question. Second part is order. That means let us consider there are 10 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
10.
Okay. A1, A2, A3. Now you tell me three of your friends' names. Number one,
Akhila.
Akhila. I will write here. Here I will write. A1 is equal to Akhila. A2.
Jatin.
Uh,
Jatin Srikhar.
Jatin Srikar. Okay, Jatin Srikar. Okay, A3.
A3 Anirudh.
Anirudh. Anirudh. Okay. Akila is thinking that I should always be in first place rather than these two.
Okay.
A2 is thinking that I should be in the middle between these two.
Okay.
A3 is thinking that I should always be in the last place among these three. Okay. Now?
Okay.
So whoever comes in first place, A1 is not bothering. A1 is bothering about A2 and A3 only. So
Okay.
first I should come before these two. A2 is in between A1 and A3, somewhere else in between. This is A2, in between somewhere else. And then A3 may be there immediately or need not be immediately, next also. So this is the specified order. Another specified order, A1 here, A2 here, A3 here. This is another order. A1,
Mm.
A2, A3, A1, A2, A3. Wherever they, what have we to get is first A1 and then somewhere else A2 and then somewhere else A3. That's the meaning of the question.
Okay.
So the question is A1, A2, A3 sit in a specified order, a particular order. That's
Mm.
the meaning of it. So how many ways these 10 can be arranged? A1 to A10 can be arranged, but the condition is between these three only. The condition is A1 and then A2 and then A3, wherever they may be in the 10 places. Like that
Okay.
the question is asked. ఓకేనమ్మా, ఎక్కడైనా ఉండొచ్చు, ఎక్కడైనా ఉండొచ్చు, కానీ ఉన్న వాళ్ళ ఈ ముగ్గురిలో A1 ఫస్ట్ రావాలా, ఆ తర్వాత మధ్యలో ఎవరైనా రాని రాకపోని మనకు సంబంధం లేదు, A2 తర్వాత ఎక్కడైనా ఉండాలి, ఆ తర్వాతనే A3 రావాలి అని అడుగుతున్నారు. అంటే ఇట్లా A2 ఇక్కడికి రాకూడదు అనమాట. ఇట్లా A2 వచ్చి A1 వస్తే స్పెసిఫైడ్ ఆర్డర్ ఈస్ బీన్ వయలేటెడ్ అంటారు.
ఓకే.
ఇలా ఉన్నప్పుడు మనం ఏం చేస్తామంటే ఈ ముగ్గురిని వీళ్ళని ఎన్ని రకాలుగా ఇంటర్చేంజ్ చేయవచ్చు? A1, A2, A3ని
10.
How many persons are there?
3.
How many places will be allotted for them? For each
3.
one, 3. How many internal arrangements?
3p3.
Good. 3p3 3 factorial. So this 3p3 3 factorial internal arrangements are not permitted.
Okay.
Isn't it?
Mm.
What is this 3p3? A1 comes first, A2, A3, and then A2 comes first, A1, A3. No, sometimes A3 first and then A1, A2. Isn't it? That is not permitted. That is
Okay.
possible in 3 factorial ways. These 3 factorial arrangements will be counted in the total 10 factorial arrangements. Is not total is 10% are there.
Yes, sir.
So these 10% without any conditions, how many ways they can arrange? 10 factorial, 10 to 10 ways. Among these 10p10 or 10 factorial ways, these 3p3 3 factorial ways are not permitted.
Okay.
Is not? Therefore, number of arrangements 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 is equal to total arrangements divided by internal arrangements among these three, or arrangements among A1, A2, A3.
Mm.
Arrangements of A1, A2, A3. This is equal to total is 10 factorial, you said, na?
Hmm.
Among A1, A2, A3 is?
3 factorial.
That's all. That's the answer.
Okay.
10 factorial divided by 3
3
factorial.
factorial.
Note on this.
Over, sir.
This is also a very frequently asking entrance question, objective entrance question. Hmm?
Okay, sir.
And also important for the public exam also. Now the next is third question. Number of ways of arranging, number of ways in which 5 red balls are there. 5 red balls. Red 5. Hmm?
Hmm.
Black 4.
Hmm.
Black 4 balls are there. Or different sizes can be arranged in a row. Condition they are keeping. First condition is no two balls of the same color come together. No two balls of the same color, no two balls of the same color come together. That's the condition. Okay.
Okay.
Now we will take, there are red balls 5 of different sizes. That means they are different among themselves. I will name them as R1, R2, R3, R4, R5. Similarly, black also different. No two balls of the same color come together is a question. So, same color balls should not be adjacent. That's the condition. What I do is, first I will arrange black, 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 black. B1, B2, B3, B4.
B.
There are 4 black balls. How many ways they can be arranged?
4.
Hmm. Inka.
4p4.
That's good. Arrangements of black balls is equal to
4.
4p4. Now, in between places, this is vacant, this is vacant, this is vacant, this is vacant, this is vacant.
Hmm.
In between places, I will take white. W1, W2, W3, W4, W5. So
Hmm.
arrangement of white balls is equal to how many?
5p5.
Good. 5 P.
P5.
There are 5 places and 5 white balls are there.
Hmm.
Hence, number of arrangements is 5p5.
Hmm.
Therefore, now you can see that white to black, white to black, white to black. Are they not alternate?
Yes, sir.
No two balls of the same color are together, isn't it?
Yes.
Therefore, required number of arrangements. Required number of arrangements is equal to 4p4 into 5p5. That's equal to 4 factorial into 5
5
factorial.
factorial.
Understood this?
Yes, sir.
This is also very, very, very important question for
Okay.
objective point of view. Hmm?
Hmm.
4p4 into 5p5. So here the white and black are coming alternate. No two of them are adjacent. Similarly, boys and girls may also be asked, and some other colors like that. They will change. Little changes may be happen. And
Hmm.
the second part is same question. Second part: the balls of the same color come together. Same color come together. Same color come together is a condition. So if we have to say that the same color is coming together, let us take that white 1, 2, 3, 4, 5 white. We put a tie for them and blacks are there now.
Mm.
B1, B2, B3, B4. We put another tie for them.
Mm.
So that were they not same color being together? All whites
Yes.
are together, all
Yes, sir.
blacks are together.
Together.
So these two units, first unit and second unit, this two units, how many ways they can be arranged?
5. Uh,
White, black, black, white, only two ways. No? This
okay.
together one unit.
Mm.
Together,
1 unit.
this is another unit.
Okay.
So there are only two units.
2, 2p2.
2p2 ways,
Mm.
isn't it?
Yes, sir.
Now, what you are saying is between these five, how many between the among these five, white, how many internal changes are possible?
Mm.
How many? There are five places, five balls are there. How many internal changes?
5p5.
5p5. That's correct. 5p5.
5.
And between these four, among these four,
4p4.
4p4. So white themselves can be internal changed in 5p5 ways. Four black can be internally changed in 4p4 ways. They are together in 2p2 ways. Is not? These three must be multiplied. Therefore, number of arrangements is equal to first one is 5p5 into second one is 4p4 into third one is 2p2. This is equal to 5 factorial into 4 factorial into 2 factorial. This is the answer for this.
Okay.
Okay,
Mm.
note it down.